All right. Hi, everyone. Hello. All right. My name is Norma Elias, and I will be your instructor for the linear algebra class. Sorry, I was a few minutes late because I have two back-to-back classes, and sometimes they interfere. Next time, I'll try to be exactly on time. So the class you guys are in is linear algebra. I will go through the syllabus with you, and then if you have any questions, we will discuss them, and after that, we start the course. So I will share the screen to discuss a little bit the, okay, here we are. Okay, so this is my name, and my office basically doesn't exist this semester, and my phone number doesn't exist either. My email is, you guys, I mean, you can read it, and I am almost always reachable on my email. Basically, I am at home most of the time, so if you guys send me an email, I will try to get back to you as fast as I can. The office hours for the course are from 11 to 12, Tuesdays, Wednesdays, 3:30 to 4:30, Monday, Wednesday. And the Zoom invite for the office hours are already on Brightspace. So you guys can have access to them very easily. And if you cannot make any of the office hours, please feel comfortable to send me an email and tell me, you know, we cannot make it. Can we arrange another Zoom meeting? And I will do that. I will arrange a special Zoom meeting with you. The text that we will be using, the text that we're using for this course is Linear Algebra and its Application, 5th edition by David Ley. We're gonna use this text, so please either buy it or rent it or whatever you want, but you have to have access to the book because all the homework will be from the book and I will follow the book. So having the book is absolutely necessary in a way or another. Now, prerequisites for the course, you're allowed in this course as long as you had passed 164 with a minimum grade of C-. So if you haven't made 164, you hadn't passed 164, you're not allowed in this class. Now the content, what are we gonna learn in this course? Okay, this is an undergraduate course in linear algebra for basically student engineering, science, and mathematics. And linear algebra is the study of linear system of equations. So we're gonna learn, which is what we will start today, how to solve system. We will learn ideas like vector spaces, linear transformation. It's a language that at this stage will not mean anything to you, but as the semester will progress, everything will be actually very clear. We will learn a lot about matrices, how we perform operation on matrices, how we use matrices to solve a system, what's determinant, what's eigenvalue, what's eigenvectors. It's actually a very basic course for all, supposedly for all your later mathematics courses. Student learning outcome, I will skip over that because at this stage they don't really make sense to you at first day. Homework, I will be assigning a homework every time we meet, but I will not collect the homework. And but the only way you guys are gonna succeed in this class or do well in your quizzes or in your exam is basically by asking the homework, by doing the homework. So the way I usually approach the homework, for those who had me before, they know how I approach this. For those who've never seen me before, the way I approach homework at the class is when I start my class, the first question for me is, what questions do you have? It means I expect you to come to class with questions about the homework I've assigned. So you can tell me, okay, we could not do this problem, we could not do this problem. So I usually start my lecture by going over the homework problem I assign. Maybe not every one of them, but enough for you to have a good grasp of the material. And I usually try to accommodate as many questions as possible, but it has to come from you. It means I want you to be able to ask me questions. And once we finish answering questions, I usually start the new material. Now quizzes, we will have 6 quizzes throughout the semester. So it will not be a quiz every week. We will have 6 quizzes and every one will be 15 to 20 minutes long. It will be held during class. The idea, the way it will be, I will put the quiz on Blackboard And you guys will log into, sorry, I will put on Brightspace. You guys will log into the Brightspace. And then the quiz will be there. You take it, and then you take a picture of it or scan it, and you upload it back into Brightspace. The quizzes, I will try to have them short this time. Usually I have them a bit longer. This time I will try to have the quizzes a little bit shorter, so we'll have enough time to deal with the technology issue. I will drop only one quiz, since I'm giving you only 6 quizzes, and I do not give makeup quizzes. So that's the rule for the quiz. Now the date for the quiz are as follows. So I did put the grade for the quizzes, and I will do my best always to remind you, you're gonna have a quiz this coming, this coming Wednesday. So these are the date for the quizzes. So next week, for example, not this week, next week, we're gonna have our first quiz, and so on and so forth. We will have 2 exams through the semester and a final. The date for the exam are given to us, and I usually stick to the date. In case we couldn't, for any reason whatsoever, we will change, but the change will be with all of you agreeing on it. But I will try to stick. If not, I will warn you ahead of time that something has to change. The grade, 25% on your quizzes and class attendance, 45% on your exams, and 30% on your final exam. Now, the last day to drop the class is November 13. My grading scale is usually the regular grading scale, so there is nothing really interesting about it. The attendance is crucial. I mean, you will never understand the material whatsoever if you guys don't come and ask questions and do the homework. So at this stage of your learning, you guys have gone through both Calculus 1, Calculus 2, and a lot of you are actually junior, or some of you are senior even. So by now you guys know, without really studying the material, there is no way you can move forward or you can pass the course. And Brightspace, you know, everything, I communicate with you through Brightspace. So it's really your responsibility to actually look at Brightspace. You will have the syllabus, you will have the homework, you will have the solution for your quizzes, you will have the review problem for your exams, and so on and so forth. Now, the office hours, I really strongly, as I said, encourage you to use my office hours for help. And if you cannot make it, we can arrange a time through Zoom, of course, to meet. And I'm telling you very clearly, tell me if you're having trouble catching up, especially in this course, can be very difficult once you're behind. So the course builds on itself. So once you're behind, you're behind. You will not be able to catch up, because what I will be doing the 5th week is going to be based on what I'm going to do the first 2 weeks. So if you're behind, you're done. You will not be able to catch up very easily. So please do not fall behind. Now, there is a tutoring channel, probably a lot of you know about it. And I gave you the website for it. Of course, all the tutoring is done through Zoom. So in case I was not available, you have any questions, and please use the tutoring. Now, Zoom etiquette, I hope I don't have you to read that. You guys, when you ask questions, please respect other students. When you're asking your question, somebody is talking, don't interrupt, wait till the person is done and talk. And I will, when we start the lecture, I will open the chat, and I strongly encourage you to use the chat. So if I ask a question, you can use the chat to answer. And I will usually look, or if you have a question, you can use chat. I usually look at chat while I am teaching, so I know exactly what questions you guys are asking, and I know also what answers you're giving me. So please use chat in class. I usually always keep up with it. The rest is, as I call them, boilerplate that I have to put on my syllabus. If any of you have any disability issue, please talk to me during my office hours so we can arrange anything that is convenient for you. And the rest is, non-discrimination, COVID-19 stuff. So the rest, I will not really go over it. Let me talk a little bit about the course. Okay. Could still be if it was down. Or whatever, what's this? Okay, everyone should change the chat view so that it's only her receiving the message, and tell her that we are having.
Yeah, we were having.
Oh, so you cannot hear me? Can you hear me?
Well,
not all the time.
It's like lagging. So sometimes it cuts out, and then it just it all sounds weird. So
Yeah, I mean, the internet is working. I don't know what else could be the issue. Are you still having trouble?
Now it's fine.
Now it's fine. Okay, please let me know because the internet didn't tell me anything. Okay. Give me 1 second, please. I'm just gonna plug the computer in. I don't know if this matters any. Okay.
Yeah, it's definitely better.
What? Is it
Definitely
fine?
better. Yeah,
Okay. Let me say a word about the course. This course is hard. It's easy at the same time. Okay. So what is easy about the course? What's hard about the course? What's easy about the course that there's not a lot of techniques. The first 2 weeks, we will learn all the techniques in this course. That's why I tell you the first 2 weeks are really crucial. So the first 2 weeks, I will tell you all the technique. There will be no other techniques later on. So that's what will be the first 2 weeks. After that, everything I will do will be based on those techniques in a way. So this part's easy. It's not like Calculus 2. You have to learn 100 techniques of integration. You have to learn 100 how to do series. You have to learn application. You have to learn that. You have to learn that. It's not this kind of course. That's not in my course. So we have one technique we're going to learn at the beginning of the course, and then we're going to use it. What's hard about the course? What's hard about the course is that it's a new language. So we're going to learn basically a language that you've never seen before. Every day, I will come up with a new word, a new vocabulary that you have to learn. And the only way to learn this course is actually to learn the vocabulary. What does every word mean? So if I sit down, I tell you, for example, okay, one of the first few words we're going to introduce is, let us say, linear independence. If you don't understand what linear independence is, you don't understand what I'm talking about. So the hard part about the course, that is a little bit abstract, not a lot, tiny bit. That's why we ask students to have done Calculus 2, because we want them to be a little bit mature mathematically. So it's a little bit abstract. The vocabulary is crucial. If you lose the vocab, you lose the course. Am I very clear? You lose the vocabulary, you lose my course. So if you don't understand the wording, you cannot move with me. So that's really the hard part of the course. That's really crucial. And so that's why you have to keep up with it. The level of abstraction is not too much. I mean, we will do it so that, you know, it won't be very abstract. Otherwise, you guys will enjoy it, I hope. Okay? Any questions before I start? Go ahead. All right, so probably this will be the last time you see my face. I have to go back to my pencil and paper and we start. Please ask questions, and if you don't understand, you know, the only way we can succeed in this course, one way, this online courses, if you participate in the course. If you don't participate of the course, it's hard for me to talk to a screen. All right, you know, I need motivation. I need students to input, tell me, okay, I don't understand, answer questions. So your contribution is crucial for the success of this course. So I'm here to help you answer all your questions, but you have to do your parts. Do your homework, of course, and ask questions and contribute to it. Okay, so I'll take it from there and we get started. So I have to go back and, okay. Okay, so the first thing we're going to do in this class is basically learn how to solve a system of what we call linear equation. So before I define linear equation in its formal way, what is an equation? So an equation is an equality between two things, piece on the left and piece on the right. What's a linear equation? Linear. What's a linear equation? A linear equation in one unknown is an equation of the form, let us say, 2x equal 4. That's a linear equation in one unknown. So a linear equation in two unknowns is something like that. 2x plus, let us say, 3y equal to 4. That's a linear equation with two unknowns. The unknowns are x and y. Now, what's a linear equation with three unknowns? I guess you see the picture. 2x, 3y, plus 4z equal to 12, for example. That's a linear equation with three unknowns. Then I can have linear equation with four unknowns, 5 unknowns, 6 unknowns, and so on and so forth. So, linear equation. Equation, as I said, equal. What does the word linear mean? What's the word linear mean? Because that's what you'll be working with. Linear means that the unknowns, x and y, they show up only with a power of 1. Means I don't have x squared. I don't have x squared. I don't have y cubed. The only power is 1. Means the unknown comes up with a power of 1. Not only that. Linear means that the way the unknown shows up are as an additive combination of each other. What do I mean by additive combination? It means that something like that, 2xy plus z equal to 4, that's an equation of three unknowns. But this equation is not linear. Not linear. Because the unknowns are multiplied by each other. It's a power of 1. It's a power of 1, but they are multiplied. That's not linear. Linear, it means they have to come as a additive combination with each other. We're gonna add them. So a linear equation is basically an equation that has the form. We can have one unknown. We can have two unknowns. We can have three unknowns. We can have 100 unknowns. You know, we can have a lot of unknowns. So if I have like a lot of unknowns, I cannot use x, y, z to denote the variable because I have a lot of them. I start to use the following notation. So suppose I have an equation with 5 unknowns. Okay, so one way to write it is 2. I don't want to write 5 letters. I can if I want, but another way to write it is like this: 2x1 plus, so when I put a subscript, I can write as many unknown as I want, like 3x2, x3, 5x5 plus 6, 1, 2, 3, sorry, that should be a 4, x5 equal to 2. That's a linear equation with 5 unknown. So the reason we're using x sub 1, x sub 2, x sub 3 is because the equation can have as many unknown as we want. So what's the formal definition of a linear equation? A linear equation in the variable x1 through xn is an equation. It means equality. The minute I say the word equation, you have to think there is an equality between two algebraic expressions. So it's an equation that can be written in the following form. A1, so x1 through xn are the unknowns. So it's a certain coefficient a1, x1, plus a2, x2, plus an, etc. an xn equal to b, where b, the right-hand side, and the coefficient a1 through an are usually given to us. So a linear equation is this type of equation. What matters is that the terms, the unknowns are not multiplied, or they are not squared. They come really in a very, very simple addition. Okay? So it's very easy to give equations which are not linear, and it's very easy to give equations which are linear. So not linear, this one, equals 6, not linear, because the power is 2. That's not linear. Another example, not linear. As I said, xy. The minute I put xy plus 3z plus w equal to 6. X, y, z, w are the unknown. That's again not linear, because the unknowns are multiplied by each other. In this course, we are only interested in linear equation. So we're not interested in those, we're not interested in those, we're interested in linear equation. All right. Now, what's the system? of linear equation. So suppose I have one linear equation equal to, what's this system? A system of linear equation. So let's write this down. It's fairly simple. A system of linear equation is a collection of one or more linear equations that involve the same variable. So a system.
This is Elias.
Yes.
Could you go up a little bit? I didn't get to finish earlier. Or yeah, back. Thank you.
Are you fine? Can I move?
Yes.
Now, so what's a system now? A system of linear equation is a collection of one or more linear equations that involve the same variable. So let us start examples of linear equation. So one example of a system is the following. So now I'm going, that's the definition, and now the example. X, let us say, minus 2y equal to 4. X plus 2y, for example, equal to 1. That's a system. The unknown are x and y's. So that's a system of two equations with two unknowns. Okay. This is called, instead of saying two equations with two unknowns, we call this 2 by 2 system. Okay, so that's a system. It means 2 equals to 1. Another example of a system. Another example is this. So suppose I take the following. For x, I'm going to use x1 just so we get used to it. Plus 2x2 plus x3 equal to 2. And let us say x1 plus x2 plus x3 equal to 2. That's a system. That's a system. How many equations? 2 equations. How many unknowns? 1, 2, 3. We give it a name. What do we call a system of 2 equations with 3 unknowns? This is called a 2 by 3 system. Okay, so how are the numbers working? The first one always tells me the number of equations. That's crucial. The number of equations. The second one will tell me the number of unknowns. Okay, so that's a system. So I can have a system, 2 equations, 3 unknowns. It don't have to be 3 equations and 3 unknowns. I can have a system with 4 equations, 5 unknowns, 4 equations, 4 unknowns, and so on and so forth. So this is a system. It means of linear equations. Each one of them is linear, as you realize. Now, what's the solution of a system? What's a solution? Suppose I have a system. What is a solution? The solution will consist of 2 numbers, x and y, that will satisfy the first and satisfy the second. So a solution of a system is, if you have a system with 2 unknowns, consists of 2 numbers that make this equation true and this equation true. In this case, what's the solution? The solution in this case is a list of 3 numbers. 1 for x1, 1 for x2, 1 for x3, that make this equation true and they make this equation true. So the most natural definition you can think of. So I can write this in a formal way, or I don't have because it's self-explanatory. What's a solution of a system of linear equation? It's a list of numbers. It depends. So if a system has an equation, n unknown, so it's a list of n numbers that makes each equation true when the values are substituted for x1 to xn respectively. Okay, so the most natural definition you can think of. Our goal, and the first goal we have in this class, is actually learn how to solve a system. So if you have a system, how do we solve? All right, let me start, let me go back to my two examples here before we start. Okay, I want to ask you the following question. Suppose I have this system, very easy system, two equations, two unknown. Who can give me a solution of this system? Who can give me a solution? I know this is easy, otherwise I wouldn't be asking you that. So the solution will have to consist of two numbers that make this equation true and this equation true. Who can give me a solution?
X is 3 and Y is 1.
X is 3 and Y is 1. Let me check. If I put X 3, Y is 1, is the first equation satisfied? 3.
-1, I'm sorry.
Which one is -1? This one? Y or X?
Yes.
Okay. 3 minus 2 times -1? No way. Let's give me 5. Okay, who can think of, are you posting notes on Brightspace? Okay.
5/2 for X.
What?
5/2 for X.
5/2 for X. Oh, sorry, I shouldn't write it here. I have to make sure. So we are guessing, but very soon we're gonna solve this very easily. So 5/2 for X, and what is it for Y?
-3/4.
-3/4. Right, let me check. X is 5/2 minus 2 times 3/4, that's 3/2. That's give me 5 plus 3, 8/2, 4, correct. Let me check the second one. 5/2 minus 2 times 3, minus 3/2, 5/2 minus 3/2, this is equal to 1, correct. So that's a solution. So for now, I'm not really worried about how to do it. I just wanted to give me a solution. All right, equation number 2. Who can give me a solution? So I want a value. So here, the solution should consist of 3 numbers that make this equation true and this true. So whatever you give me, I'm checking. Who can give me a solution?
X1 equal to 0,
0.
X2 equal to 0,
Yep.
and X3 equal to 2.
Okay, let's check it. And then I write it. 0, 0, 2, satisfied. 0, 0, 2, satisfied. So I'll accept that. Who can give me another solution? Can anybody give me another solution? Come on, there are quite a bit of you. You should be able to give me another one.
Wait, are we talking about the top equation or the?
This one.
Oh,
I want another solution for this. Anybody?
wait, would it be 6 for X3, and 1 for, oh wait, no, nope, never mind.
Anybody is faster?
I think I found one.
Go ahead.
1 for x1,
Okay.
negative 3 for x2,
Mhm.
and then 4 for x3.
Okay, I'll check. 4 minus 6 plus 4 equal to 2, correct. I have to check the other one. 1 minus 3, sorry. 1 minus 3 plus 4. Okay, 1 plus 4 equal to 2, correct. So 1 minus 3 and 4. Do you think we can find more solution?
Yeah, I got -2, 5 and 0.
Okay. So this is a system, you know, you guys were able to give me 3 different solutions. And eventually what we are going to show that this system have infinitely many. And you're going to be able to find every single one of them. Okay, so you guys gave me 1, 2, 3. I can give you a lot more. And actually we're gonna learn how to find a lot of them. All right, I'm gonna give you one more system. I'm gonna ask you the same question, exactly. And then, and it's gonna be easy, but I want you to watch what I'm going to do. I'm gonna take the first one, like the one before it. That's my first equation. I'm taking my second equation, as you realize, the same thing as before. And I'm gonna play a very, you know, not very, a small game. So I'm gonna put 2x1 here. And I'm gonna put here 3. What can we say about this system? So that's a 3 by 3 system. Now, can anybody give me does anybody have anything to say? I want you to look carefully what I'm doing. Absolutely. Somebody told me something that makes sense. What does it mean though? So somebody wrote on chat something that actually makes sense. Second and third are parallel. I will talk what he mean by that, but what does it mean in terms of solution? There is no solution. The system, you can do anything you want. You will not find a solution. And I will give you an algebraic reason, not a geometric reason. Yeah. If I take this equation, x1 plus x2 plus x3 equal to 2, and I take this last one, what did I do actually? I multiplied the right side by 2, the left side by 2. So any 3 numbers that satisfy the second equation, if I multiply the left side by 2, this should have been not a 2, this should have been a 4. So any 3 numbers satisfy this equation, when I multiply this by 2, by 2, by 2, I should get a 4, not a 3. Means this equation and this equations, geometrically, this equation represents a plane in R3. This equation represents a plane, and this represents a plane. Those 2 planes are parallel, they do not intersect. So this system actually has no solution. So you can do anything you want, and you cannot find anything that satisfy this and this and that. Because any 3 numbers that satisfy this particular equation, when I multiply it by 2, this should give me a 4 if the numbers satisfy this equation. But here I'm giving you, I want this to be 3. And so there is no way that this piece could be 4 and 3 at the same time. So this system will have no solution. Let me talk a little bit more about what I'm giving you in those examples. In problem number 1, you guys gave me a solution. Do you think there is another solution of this system? or that's the only solution we can have? Geometrically, what does the solution represent? What does the solution represent geometrically? Every x and y that satisfy the system has to satisfy this equation. What does it mean to satisfy this equation? It means the point xy that satisfies this exactly has to be a point on this line. And if I take this line and I graph it, so if x is 0, sorry, if y is 0, x is 4, for example. If x is 0, y is -2, it means if I take this line equal to 4, and I take this line, x plus 2y equal to 1. If y is 0, x is 1. And if x is 0, y equal a half. So every x and y that satisfies this system, it will satisfy the first equation. It means the point has to be on this line. It satisfies this equation. It means the point has to be on this line. So the solution is actually the intersection of those two lines. Now those two lines intersect at one point. So we're going to have exactly one solution of the system. There is no way the system will have actually two solutions. Okay. Now the system, of course, it has infinitely many. Now for those who had 261, not all of you should have had it. If we schedule the point in R3 that satisfies this equation and this equation, we get a plane and we get a plane. So what those systems represent, the intersection of two planes which are not parallel to each other. So if you have one plane and you have another plane, the two planes intersect along a line, it means you're going to have a lot of solution. And this one have no solution. This is going to bring up the following definition. Every system of linear equation either has a solution or doesn't have. If the system has a solution, we're going to give it a name. And we are going to call it a consistent system. So consistent system is a system where there is a solution. Sometimes a system doesn't have a solution, like here. We will call this an inconsistent system. So inconsistent system is a system that has no solution, and a consistent system is a system that has at least one solution. Before I give you the formal definition, which is exactly, I'm going to repeat it myself. To understand inconsistency, I will ask one of you the following. Suppose I take x minus 2y equal to 4. That's my first equation. Who can give me another equation so the resulting system is inconsistent? Just to convince you how the system is inconsistent in the simple scenario of two variables. Who can give me another equation that forces the system to be inconsistent? Quickly.
2x minus 8y
minus 8y
is equal to 5.
Equal to 5. Absolutely correct. No, that's not what you want. You want to x minus 4y.
My bad. Yeah. 4y.
Right? Understand? The student multiplied the first equation by 2, 2x minus 4y. For it to make sense, this has to be 8. You put 5. The system will not have a solution. And graphically, what's going to happen? X minus 2y equal 4 is going to be this line. 2x minus 4y equal to 5 is going to be parallel to it. The system will be inconsistent. All right? So, this leads me to the following. A system of linear equation is said to be consistent if it has at least one solution. If the system has no solution, we say it is inconsistent. And here we have two examples, inconsistent, and the other example that I gave you before is also inconsistent. So every system could have or fail to have a solution. And of course, our goal is how do we know? I mean, so far we're playing simple games, but when we have a lot of equations, the question is, how do I know whether we have a solution? Or how do I know that we don't have a solution? Another interesting thing about a system of linear equation is the following. If the system is inconsistent, it means it doesn't have solution. I am done. If the system is consistent, then the scenario is interesting because we don't have to have one solution only. In this scenario, the solution is unique because geometrically, the intersection is a point. In this, I have more than one solution. You guys already gave me 3 different solutions. So if you have a linear system, if it's a consistent, the solution could be unique. It means only one, or the other scenario will be not only not unique, but infinite. Like in this scenario, actually we can find infinitely many because those are geometrically the intersection of 2 planes. So let me summarize this a little bit. So let me summarize this. System, every system of linear equation is consistent. It means has solution, or inconsistent. Consistent means has solution, no solution. If it has solution, we're going to have 2 different scenarios. Either we have only one, we call it unique, only one, or we have not 2, infinitely many. Okay. Now let me talk, what does it mean infinitely many? Infinitely many means that a system cannot have only 2 solutions. So either one or a lot of them. Either one or infinitely many of them. And this is the characterization of linear systems. So once we have one, either it's the only one, or once we have 2, I have infinitely many of them. And that's what we are going basically to be able to, be able to figure out once we solve the system. Okay. So today it's going to be introduction to how we're going to solve system in a very algorithmic way. How we're going to know that the system has one solution. How we're going to know that the system is inconsistent. How we are going to solve a system. So before we do that, I need to introduce something called a matrix. And a matrix is just, we're going to use it now to help us write a system in a very comfortable way. So what is a matrix? What is a matrix? A matrix is nothing more than a rectangular array of numbers. So I put bracket, and inside the bracket, I put numbers. So I'm just going to make up numbers. 1, -1, 2, 3, 0, 1, 2, -1, 4, 2, 1, 1, 3. So that's a matrix. It's nothing more than an array of numbers. We'll put stuff in it. Now, this is called, so this matrix, it has 1, 2, 3 rows. So this is called the first row of the matrix. This is the second row, the third row, and this is the fourth row of the matrix. So this is first row, second row, third row, fourth row. Those are the rows of the matrix. And then we have the columns. This is the first column of the matrix, second column of the matrix, and the third column of the matrix. So first column of the matrix. This matrix is called a 4 by 3 matrix. What does the first number represent? What does the second represent? The first represent the number of rows, always. The second represent the number of columns. So for us, a matrix now is nothing deeper than that. It's just this rectangular array. Nothing really more, nothing, that's it, that's what it is. So if I write a 5 by 3 matrix, I mean just a rectangular array that has 5 rows, 1, 2, 3, 4, 5, and has 3 columns. That's what a 5 by 3 matrix is. Why are we introducing matrices at the same time we're talking about system? I mean, the idea, okay, where did you bring this from? We are going to use matrices basically as a compact way to represent a system. So what do I mean by that? Suppose I have a following system. I'm just going to make up a system. So I have the system, whatever, make up something, x1 minus 2x2 plus x3 equal to 2. And 2x1 plus x2 minus x3 equal to 4. Okay, and let me one more. For example, 3x1 plus 2x2. I'm not solving, I'm not doing anything, it's just equal to 5. That's a system. We're going to introduce, the reason we introduce the idea of matrices is a way to write a system in a compact way. That's really why we're using it. Now, to every system, we are going to associate 2 matrices. First one, we are going to call it the coefficient matrix. What does the coefficient matrix has in it? The word coefficient, where is coming from? In this scenario, the coefficient of x1 is 1. Coefficient of x2 minus 2. Coefficient of x3 is 1. All right? The coefficient matrix will be like that. I will explain it row-wise and column-wise. The first row, it will have coefficient of x1, coefficient of x2, coefficient of x3. That's the first row. Second row, coefficient of x1, coefficient of x2, coefficient of x3. Third row, 3, 2, minus 4. That's the coefficient matrix. So column-wise, what's happening? What does the first column has in the coefficient matrix? Coefficient of x1, coefficient of x2, coefficient of x3. What about the second column? Coefficient of x2, coefficient of x2 in the second equation, coefficient of x3 in the third equation. That's what we call the coefficient matrix. But this matrix does not really represent the whole picture because it's skipping those terms. So we're gonna also associate to every matrix, to every system, another matrix. That's gonna capture everything inside the system. And this one will be called the augmented matrix. Very simple ideas, actually. What's the augmented matrix? The augmented matrix actually is gonna capture all the information within the matrix. So I'm gonna be, the book does not draw this dotted line, but I really like to draw it. So what does it have? The first row should basically reflect the first equation. So the coefficient of x1 minus 2, 1, 2. So we're gonna augment those terms to the right. That's the difference between the augmented and the coefficient. 2, 1, minus 1, 4. 3, 2, minus 4, 5. So every piece of information in the system is captured in the matrix. There's nothing more than, as I repeat several times, it's just a way to, instead of writing x1, x2, x3 all the time, I just capture this information within the matrix. So, very simple example. Suppose I give you the following matrix and I tell you this matrix is the augmented matrix of a system. So I'm going to write 0, 2, 1, and minus 1, 4, 3, 1, 5. Okay, I'll tell you this is the augmented matrix of a system. Write the system that corresponds to it. Is that my question clear? So, what's the system that corresponds to this augmented matrix?
So it would be 1x1
1x1
plus 2x2
plus 2x2
plus 2x4. Or would
Right.
that be
Yeah, absolutely. 0x3. What goes here, those are the coefficients of x3 in the first and the second equation. Plus 2x4 equal to 1. All right?
Will we have to write 0x3, or could we just skip to?
No, you don't. No, you don't. I am doing it right now to just tell you that what's really happening here. No, you don't. And actually, I won't either. It's up to you to know that. Minus x1 plus 4x2 plus 3x3 plus x4 equal to 5. Okay, so the number of rows correspond to the number of equation. The number of the columns to the left of the last column will represent the number of unknown. So this augmented matrix corresponds to a system of 2 equations and 4 unknown. So it's very important to know what's happening. So one more example before we start solving at least one system today. Okay, suppose I do that. So I want to totally understand 1, 2, 3, 4, 6, 1, 8, minus 2, 1. Okay, we're not solving. Okay, I tell you this is the augmented matrix of a system. My question to you is, how many equations will the system have and how many unknown will the system have? Quickly. This is the augmented matrix of a system. How many equations will the system have?
3 equations with 2 unknowns.
Exactly. The rows are the equations. How many equations? 1 unknown, 2 unknown. Okay, so the system would be x1. So that's really why we're using mesh. Instead of writing x1, x2, x3, we just say, you know, we can take all this info and put them inside a matrix. That's what we are using it for now. Equal to. Okay, so it's not really hard. It's just, you know, it makes writing easier. Okay, so now where we're at. We developed a compactor for writing a system. Now our goal is to learn really how to solve the system. You know, the examples I gave you are basically fairly simple. I gave you a 2x2 equations. I asked you to guess. I gave you a 2x3 system and I asked you to guess the solution. So I picked it so that you guys can guess the solution. And then I made up this problem of 2 parallel lines basically to tell you that sometimes the system have no solution at all. Now what we're going to start is how to solve a system. Now I can give you a system, tell you solve it. I know you know how to do it, but every one of you is going to do it in a different way. And some of you are going to spend 5 minutes, some of you are going to spend probably half an hour. My goal is that we all spend 5 minutes to solve a system. So today we're just the beginning, the introduction to the idea, and next time we actually take off. So I'm going to take a system. Okay, and we're gonna solve the system. Let me take a white paper. Slowly, white paper. I want a white paper. Yeah. All right. This is a system. Do you guys see the system?
Okay.
Okay. All right. Do you see it? X1. Don't worry about that. Don't worry at all about that. So the first is x1 minus x2 minus x3 equal to 2. 3x1 minus x2 plus 2x2 equal to 16. And actually, I think I would rather do it that. equal to 2. The second is 3x1. So by writing it with you, you guys 2x3 equals 16. And the last equation is 2x1 minus x2 plus x3 equal to 9. This is the system we would like to solve. What does it mean to solve? It means find the values of x1, x2, x3 to satisfy this equation and this and that. If I throw this problem at you, do you think it's easy or hard? What do you think? Okay, let's see how we're gonna solve it and the algorithm that we're gonna solve it. The way we're gonna solve it is we're gonna use a technique that we call the elimination process. How the elimination would work. The way we will do is like this. I'm going to try to, and something you guys have seen in high school, but now we're going to make it more formal. I will try to use the first equation to eliminate somehow the coefficient of x1 in the second equation. So how I'm going to do that? So this way I'm going to hold on to it. I'm going to eliminate that. To eliminate that, I need to do the following operation. I'm going to take the first equation.
And solve for x1, right?
No,
And solve for x1.
absolutely not. That's a nightmare. What's what we're going to do? I am going to multiply it by -3. Once I do the first, you guys will be able to follow me and add it to the second equation. And I'm going to basically replace equation 2 by that. I'll explain verbatim what is going to happen. So that's where the word elimination is coming from. I am going to try to eliminate x1. So let's see what I do. I will do the first problem in details and then slowly we'll do less details. So what's -3 equation 1? What do I mean by -3 equation 1? Equation 1 is x1 minus x2 minus x3 equal to 2. -3 equation 1, it means I'm going to take this whole equation multiplied by -3. What do I get? So -3 equation 1 is the following equation. -3x1 minus plus 3x2 plus 3x3 equal -3 times 2 -6. I'm going to add this to equation 2. What's equation 2? 3x1 minus x2 plus 2x3 equal 60. I'm going to add them. Let's add them. -3x1 plus 3x1, they cancel each other out. That's what I am after. That's what the word elimination came from. I'm going to eliminate the x1 from the second equation. So this would give me 2x2, and this would give me 5x3, and this would give me 10. Right? Now what I'm going to do is I'm going to replace this system, replace it by a whole new system. What's the new system? I'm going to keep the first equation intact. I will keep the last equation intact in its place. It means I will not change what it is. It's the third, I keep it the third. It's the second equation that I'm going to replace the second equation by what I got here, by -3x1 plus equation 2. So instead of the second equation, I'm going to have 2x2 plus 5x3 equal to 10. Okay, that's what the elimination process is. So I'm going to eliminate now. Mathematically, this system and that system have the same solution. It means every value of x1, x2, x3 that will satisfy the system will have to satisfy that, because this remains the same and this is remaining the same. Every number that satisfies equation 1, even when I multiply by -3, they have to satisfy this. And they satisfy equation 2. So any three numbers that satisfy equation 1 and equation 2 will have to satisfy the third equation. Meaning that performing this operation on the equation will not change the solution. We say that this system and this system are equivalent. It means they have the same solution. Okay, so if I go back to my notes here, that's my system. And what did I do? That's the coefficient of x1. I multiplied the first equation by -3, added to the second, and I created a new system. That's the new system that we explained it right here. Those two are equivalent. We say that they are equivalent. Equivalent means they have the same solution. Now, what I'm going to do after that? I will almost now know what we should do. I have a new system now, which is this one, to be very clear. Now I'm going to repeat the process. I'm going to use x1 to eliminate, so I'm going to use this first equation to eliminate the x1 in the third equation. So I won't have x1 except in the first one. So what operation I'm supposed to do? So how can I eliminate the 2x1? I'm going to take the first equation
And multiply by -2.
by -2. I'm going to add it to the third equation. I'm going to get a new one. This new one will become, so this will become the new, so this become the new equation 3. Or we can write, replace equation 3 by -2, equation 1 plus equation 3. That's the process we are doing. All right, if I do this process, what will I get? Okay, let's see what will I get. So my first equation, I am not touching. My second, I am not touching because I've already eliminated x1 from it. It's here that I'm going to eliminate. Now, I'm going to multiply this by -2 and add it. Okay, I can do it on the side like this, or you can do it mentally. It's really whatever you want. So let's do it mentally. -2 x1 plus 2x2, 0 x1. I'm done with x1. Now I have to multiply this by -2. Minus plus 2x2 minus x2. I'm going to have an x2 in here. Now I'm multiplying this by minus 2x3 plus x3. I'm going to have 3x3 equal. -2 is going to give me times 2. That's a -4 plus 9 is going to give me a 5. Are you with me so far? Ask questions,
Yeah.
please, as you go on. So now what did I do? Step number 1, it took us a lot of time to do it because I'm explaining it, but usually it shouldn't. So I eliminated x1 in the second equation, and I eliminated x1 in the third equation. And mathematically, this will not affect the solution. It means all the numbers that satisfy, all the numbers, x1, x2, x3, satisfy this system will satisfy that, will satisfy my original system. Now what I'm going to do, I eliminate for x1. Now I'm going to move and start repeating myself for x2. Means somehow I want to eliminate the x2 in here. How can I do that?
I'll multiply the third equation by -2, correct?
Multiply this by -2 and add it.
Yeah.
Okay, I will do that, but because eventually I want to make a point and I'm a bit slow. So before I do what you asked me, which is, I'm going to make an extra step. I'm going to first exchange equation 2 and equation 3. Does this matter much? I don't think so. And then I will do exactly what you asked me to do. Because I think clearly from top to bottom. To x2. So at this stage, I really didn't do anything. I just switched equation. And now I'll do exactly what your classmate told me to do. Okay, he told me that I want to eliminate this x2. So he told me, okay, replace equation 3 by minus 2 equation 2 plus equation 3. That's the operation we're doing. Very good. I will do the operation. Gonna leave me with x1 minus x2 equal to 2. Very good. x2 plus x3 equal to 5. And now I multiply this by minus 2 and add it. Minus 2 plus 2, that's a 0. Minus 6 plus 5, that's give me the minus x3. And then minus 10 plus 10, give me 0. Okay? So now I have this system. I'm going to ask you the question. Is this easy to solve? If you look at the system, can you give me the solution of this?
X3 should be 0.
X3 should be 0. It has to be. What about x2?
5.
x2 has to be 5. We don't really have much thinking to do. 0, it's 5. What about x1? So let us see. x3 is 0. I'm going to back up. x2 plus 0 equal 5. x2 equal to 5. I know x3 and I know I'm going to back up. Now I want x1.
Is it 7?
Yeah.
Yeah, let me check. x2 is 5. And this is 0 equal to 2. x1 equal to 7. That's my solution. This process, going from x3, then backing up, substituting 0 for x3 to get x2, then substituting 0 for x3 and 5 for x2 to get x1 is called back substitution. Back substitution. Okay. So when I reach the stage where I can basically, once the system have like some kind of a triangular shape, if you want, and then I can actually start solving in a very easy way. So my solution is 750. Now, even though it took us a while to do it, but actually it was not really a very hard way to do it. Now let me check. Let me check, because I'm usually do a lot of mistakes. Is it a solution? So we got 750. Let's check. All right. 7 minus 5 is a 2, satisfied. Now this one, 3 times 7, 21. 21, take away 5, that's going to give me a 16. Plus 0, 16, absolutely satisfied. This one, 2 times 7, 14. 14 minus 5, that's a 9. Absolutely satisfied. And the solution is 750. So let us repeat the process. What did we do? What we did is, we started with the coefficient of x1. Then we used the first equation to eliminate the x1 from the second equation by doing minus 3x1 plus 3x1. So we did this operation. Minus 3, equation 1, plus equation 2, give me equation, that will become the new equation 2. We got a new system. Then we kept the same process. I tried to eliminate x1 from here, from the third equation. So I multiplied the first equation by minus 2, added to the third, and this new equation will become my equation 3. I got that. And then, so I'm done. I eliminated everything. Now x2 is my problem. I repeated the same thing. I said, I forget now about equation 1. It did its job. Now I want to eliminate x2 here. So I said, you know, it's easy for me to flip them. I flipped the equation. And then I want to eliminate the 2x2. So I multiplied the second row by 2. I ended up with the system. Now we can spot it and solve it. Now we use back substitution. And we get x3 0, x2 5, and x1 is 7. Okay, so that's really the idea. Now, let us say I wanna, is the time up? 3:15, okay. I think the time is up. I have to stop. Now, next time what we are going to do is actually, instead of performing those on the equation, I'm gonna start performing those operations on the matrices. So instead of always writing x1, x2, x3, my question is, you know, can we do it? How about, what can we do if we take this and we go to the matrix? How can I operate on the matrix instead of operating on the system? And how we can solve the system, all right? So I think that's it for today. It's 3:15. Time is up, right? I'm confused. No, time is up. And next time, as I said, we will start with matrices, and then we will start with the language that we need to solve any possible system. Okay. One student asked me, can I post the notes? Not the notes. What I will be posting is actually the lecture itself. Okay, the lecture is being recorded, and it will be eventually put on Brightspace. All right. Any question before we quit for the day?
Nope.
Questions?
Excuse me.
What?
Excuse me.
Any questions?
May I ask a question?
Of course.
Yes. So this whole thank you. So this whole back substitution process we did was to simplify the system of equations down to a point where we can see the answer, and then back substitute it into the equation so that
absolutely correct.
The solution.
Absolutely correct. Everything we're doing is a way to simplify the system. And
okay.
So we can reach a format that looks like this. That's what our goal. Our goal is to reach that, this triangular form. But we have to do it in a very algorithmic way, because if we don't have a specific algorithm, you know, it will be jumble mumble and you cannot get anywhere. Okay, so the algorithm that I try to introduce today, x1 move to x2, is actually the best algorithm to be able to reach exactly that format. Okay?
All right.
There is an order which to eliminate.
Okay, please ask. I couldn't hear you.
No, I was just asking. So there is an order that you have to eliminate the unknowns by. So you have to.
Yes. Yeah. And you're gonna learn exactly that order. We're gonna learn this algorithm because it's the fastest. You see, it is as a whole the fastest way to get it. Otherwise, it will be very messed up. Any other questions? Okay, good luck. Go ahead. Okay, good luck for the semester, and I'll be seeing you on Wednesday. Okay, bye.